Okay, we're collecting data here now. Pablo, you have a relay that is controlling your the very front end of your antenna feed.
Correct.
Way out at the very front of your antenna feed, you have a Noelec Sawbird H1 Plus bare bones low noise amplifier, LNA.
With a 50 ohm load switch that allows me to,
Correct.
from
And the
the
bare bones has a fancy little 4-pin connector where you are allowed to control this amplifier in a different way. Inside it has a circuitry. If you short 2 pins on that 4-pin connector, it will, instead of looking at the antenna input connector, it will look at a resistor that it has on the board. Now, that resistor is on Earth and in the atmosphere, so it's about 70 degrees Fahrenheit, which is like 250, what was it, 230 or something like that, Kelvin. So anyway, it's a hot resistor as far as radio astronomy is concerned, as opposed to looking at the cold sky above us, which is maybe 10 degrees Kelvin as far as energy coming at it. Kelvin is a measure of power this way,
okay.
energy. Um, what we're looking at now is the spectrum, the big red curvy thing on the left, and it's changing. Um, right now it has a slight bump on it. Now it's just kind of gone flat, very smooth curve. The smooth curve is the resistor. We're going to use that resistor as a reference sample to compare to. Here's
Oh.
the hydrogen back with the little bump in the center of that spectrum. Uh, way over on the right, can you move your cursor to the R? We see this little R come and go. When it's showing, the graph on the left represents a reference sample. And the R has now gone away, showing that that's looking at the antenna sample.
So, so what you're saying, so that I can understand, is that your program, ezRA, Easy Radio Astronomy data collector, is actually controlling the USB switch automatically every two samples and switching to the resistor.
On every sample, before every sample, it's talking to that relay. Either it's turning it on or turning it off. And that relay is wired way out to your feed, and shorting pin one. I think it's pin one, or is it pin 3 and 4? Do check that.
Yeah, I forget.
But anyway, shorting 2 pins on the connector. I think 3 and 4. Um, and so we're seeing a different result. We're either looking at the sky where we see a little bump of hydrogen in the spectrum, like now, a little bump over on the left, or we're looking at the resistor, which doesn't have any hydrogen frequency response in it, and
It,
it's smooth like it is now.
it
They
amazed
are
me
both on the same frequency.
because we're right in between galaxy arms right here, so we're still picking up the hydrogen line, even though it's
Yeah, it's close enough though. There's enough hydrogen all around that galaxy.
yeah.
Um, and so we're seeing the spectrum change from reference to antenna signal, back and forth. Now, if you'll click on the ref div up on the top right, we will take each antenna sample and divide it by frequency by frequency all the way across by the last reference sample. So antenna sample divided by the reference sample. And it makes a kind of a more dramatic bump. And that's the key.
Now, what if we try reference subtraction?
Sure. And then that math, I didn't know which one was better. And so ref sub takes every antenna sample value and subtracts the the last reference sample.
Oh,
Um, let's let it cycle another time, but it doesn't quite look as flat.
no, there's a little bump there.
All right, so this is ref sub. I kind of like the ref div better.
Yeah, I agree.
And that's been my experience. I don't know if it's mathematically correct, but it makes a prettier picture. And that's really all I'm really trying to do in many ways with ezRA or ezRA to highlight the hydrogen. So we're doing a couple of samples here while it finally catches up. Oh, we're still on ref sub. We haven't gone to ref div.
Oh, I'm sorry. I thought I
Uh,
did.
it could be that my program didn't catch it.
Maybe I should go to off first. Maybe. Oh no, there you go.
No, 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 no. We just got to give it a chance. And then we'll give it a couple of samples. There we go. And to me, this is a little more obvious where the hydrogen is. It's in the same place where we saw a bump earlier, but it's more zoomed in. It's more magnified, is perhaps the right word. Um, it is kind of arbitrary, though. On the left-hand side of that spectrum graph, you can see 1.0. So this is the relative measurements of those two things as far as energy. And I'm not sure it has much meaning there. But ezRA doesn't worry about absolute measurements. It only worries about relative measurements that it has taken. I don't know if it's very good at comparing to other people's data, but of the data inside ezRA, it will compare between those values. And that's what's going on here.
This is a
Relative
magnificent
power.
program. I mean, just this display and control, it's fantastic. But you're able to create like 50 graphs, including a complete picture of the universe of our galaxy in radio with this. So this makes it an amazing program. And now,
Well, it's actually worse than that, though. ezRA's policy is sure, go ahead, make the graph anyway. And if you don't like it, you can always delete it later. I mean, you could even automate that, or you could just ask not to make that graph. There are ways to do that too. Um, ezCon is the next program to take this data and chew on it, and it makes about 70 plots, I think. Um,
70. Okay.
and then the next one does another 70 or 80. And then after that, you could have ezSky do at least 20, if not about 300. So ezRA's policy is sure, go ahead, make the plot. Uh, the key is, can you explain what the plot is saying? And if you can't, then there's some learning to do, or maybe there's something goofy about your data and you should study it more um, and find out what's going on. And so that's the policy.
And now you've modified it so it actually controls that resistor. Uh,
You have a certain way to control the relay, and it was a different language than what I was familiar with. So this is an experimental program. You can see by the program name up at the top right. Um, it's got ezCol X for experimental. That's my cute little method. And then P for Pablo, because his relay was different than mine. And then the date. This was done on December 20th. 22 is when I wrote the thing first. And we've now just corrected the program to actually talk to your relay. There was a couple of typos and some learning going on there. And so now we can control two kinds of relays, and that's good. Um, just by editing the code a little bit to match your relay. So at this point, you are now collecting data into a file. It has a file name. Can you move the cursor up to it there? Just above sample quantity. You are putting it in a file called MLO, and then the date. Today is 2000, uh, 2023, January, so we get an 01 and the 8th day, and we are in the second hour of the UTC day here after your what must be 4 o'clock or something. is the beginning of UTC for you. And we did this a couple of times, so we're up to the letter D. But anyway, that's the data file. It will keep running until something happens, maybe for almost 24 hours or 22 hours until UTC midnight again, and it starts a new file. We're up to 82 samples, now 83, as it says just to the right of that cursor, um, and collecting data.
Magnificent.
So we'll talk again when we can and
I'm
take a
gonna
look at the data. Thanks very much, Pablo.